Alright, in this video we are going to take a look at our mole particle conversions. Okay, so for this you're going to need this worksheet, which again goes into the general overview, and then we're going to look at the second page for the mole particle conversions. You are also going to need your trusty mole map, okay, which we can see here. Hopefully you have your own paper. Okay, we're going to be dealing with the conversions between moles and particles, and this is where we're going to use Avogadro's number, that's 6.02 times 10 to the 23rd. We are also going to need a calculator. Now, one thing I want to point out is if you are using the calculator on your computer, okay, which I do recommend, is we have to get the scientific version because we're going to be using exponents, okay? So if you do not have the scientific version of the calculator, what you're going to do is at the top of your screen where you see view, okay, right now you may have the basic, which is the small calculator. Well, we want the scientific. Okay, so if you go to view and change it to scientific, I'll show you how we're going to use this calculator for these conversions. If you do not have the scientific calculator, you are not going to be able to do these conversions. Okay, so for the mole particle conversions, like I mentioned, we're going to be using the upper right hand side of our mole map, and we're going to be using Avogadro's number. Okay, so first let's look at our example. How many moles of magnesium is 3.01 times 10 to the 22nd atoms of magnesium? Okay, just like all of the other problems, let's figure out what we need to get to, what we're given. Okay, well, it says how many moles. Okay, so we know we're going to have to finish in moles. That's our question, that's our ending point. And we know we have 3.01 times 10 to the 22nd atoms. Okay, now if you remember from my other videos, I talked about atoms as a type of particle. Okay, so that's our starting point. So if we check our mole map, we are given atoms, given our particles. So we're starting in particle plaza, and we have to get to mole. So I'm going to follow this arrow that's going down to Moletown. Okay, and then I'm going to use this conversion, 1 mole over 6.02 times 10 to the 23rd particles. Now, instead of particles, we're going to use atoms. Okay, but they both mean the exact same thing. Okay, this is the conversion factor we're going to use because we're taking this arrow to get from particle plaza to Moletown. Okay, so I write down my starting point, 3.01 times 10 to the 22nd atoms. Then I'm going to multiply it by my conversion factor. 1 mole divided by 6.02 times 10 to the 23rd atoms. Okay, I changed the particles to atoms because that is the unit that I'm using. By doing this conversion, my atoms will cancel. You can see that here. And the only unit left over is mole, and that is exactly what I am looking for. How many moles? Now the question becomes, how do I actually put this into my calculator? Now, the tricky part comes with this times 10 to the 22nd or times 10 to the 23rd. This is our exponent. This number is very large given in scientific notation. So let me show you how we can do this. Okay, we have our scientific calculator. We type in 3.01. Now, to get the times 10 part, you're going to hit the button where you see the EE, the 2 capital E's. Okay, this is a way to represent exponential notation. So when I hit that, that is like saying times 10. Then I just type in whatever my exponent is, 22. Okay, 3.01 E22 is the same thing as saying 3.01 times 10 to the 22nd power. Okay, now according to the math, I'm going to multiply it by 1 and then divide it by 6.02 times 10 to the 23rd. So I'm going to take the original number that's in my calculator, and I'm going to divide it by 6.02 times 10, remember, hit that EE, that exponential notation, and then type in 23. By doing this, I then hit the equals button, and I get 0.05, and that matches the number that is already given to you. Okay, so get used to this exponential notation button, because you're going to have to use it anytime we deal with Avogadro's number and we're dealing with these mole particle conversions. Okay, why don't we take a look at an example together? Okay, number 1 says, how many molecules are there in 4.00 moles of glucose, which is C6H12O6? Okay, let's figure out, what are we given, what do we know, what are we trying to find? Well, we are given 4.00 moles. We know that. That's what number is given to us. What we don't know is how many molecules there are. So, we know what we have. We know what we have to find. Let's double check our mole map. Okay? We're given moles. Okay? So we're starting right in the middle of our mole map. And we have to get to particle plaza because we're dealing with molecules. Okay, these are really small particles. So we're going to follow the arrow going up and to the right, going from mole town to particle plaza. We're going to use this conversion factor, 6.02 times 10 to the 23rd particles, which we're going to use molecules in this question, divided by 1 mole. Okay, so let's go ahead and try and figure out how we can put this in our document. Okay, what I'm gonna do is, like always, I'm gonna copy my problem down, and I'm gonna start by writing what I know. So 4.00 moles. Okay, that's my given. Now this is where the tricky part comes in. Okay, we have to, according to our mole map, put 6.02 times 10 to the 23rd on top and 1 mole on the bottom. Okay, well, that just means we need to rotate this. So I'm going to see if I copy that. There we go. I can put 6.02 times 10 to the 23rd. Now I want to change it to molecules because that is what I'm looking for. And then on the bottom, according to the mole map, it said I need to put 1 mole, right? 6.02 times 10 to the 23rd on top, 1 mole on the bottom. Okay. Now I have to check, do my units cancel, and then do the math. Well, I have moles here and moles on the bottom, so those will cancel, and I'm left with molecules on top. And it's question, remember, asked, how many molecules are there? So let's go ahead and look at our calculator. So I'm going to start with 4.00 moles, and I'm going to multiply it times 6.02. Now we have our times 10. Do you remember what button you have to push? Right? The EE, the exponential notation. And then I'm going to put times 10 to the 23rd. So 6.02 E23. I hit the equals button, and I get 2.408 times 10 to the 24th. Remember, the E24 means times 10. Okay, so I'm going to just hit paste so I can get this answer back. And if I check my calculator, 2.408 times 10 to the 24th molecules. And of course, I'm going to insert my box so you can clearly see what the answer is. Okay, 2.408 times 10 to the 24th molecules. Okay, so now with these two problems, you see both examples of the conversions going one direction and then going in the other. Okay, so for the rest of these problems, consider what you're given, what you're looking for, and then look at these two examples to help you figure out which way you have to go, which conversion factor you need to use.